let's just start. Hello, everyone. My name is Max Parzen. I'm co-founder and CEO of Open Energy Transition. We are really thrilled to have you here today at this webinar. We had around 1,000 registrations now for this webinar, and there are a lot of people on the live stream, and here more and more people joining. And I think these numbers, they're telling us one thing, that there's really a huge appetite for people to understand the role of open source energy planning. And just to spend here also a few words on OET, if you don't know us. We are a non-profit founded 2 years ago. We have a rapid growing team of around 50 people now across 20 countries. And our mission is super simple. We aim to accelerate the energy transition with open source software, open data, and open collaboration. And that means we're a little bit of a weird tech NGO, and that really can help you in many areas around this topic. And today we will actually show you how all those open source tools are ready for powering real world grids, and are also used for energy planning. We have a couple of grid operators here, regulators, NGOs, and other industry folks joining us with exciting talks. And hopefully at the end of the event, you come out of this event and say, okay, you got the message. Open source isn't just experimental, it's really industry ready. And really thanks for all of you for joining us today. Really excited about where things go. There are some unknown variables with the panel and the lightning talks for me. So what to expect today? We start with an introduction. We launch a new app that we developed recently within the last 12 weeks. And then after that, we're having small panel discussions with a lot of possibilities for the audience to actually engage. So please get your keyboard ready and type in your questions to have them ready. And we will prioritize them and ask them to the individual panelists and speakers. And after that, after the panel, we just have a small lightning talk as well. So it's always a 6-minute talk by 6 different organizations, and a 4-minute Q&A for the audience to really ask questions. So again, be ready, listen, stay tuned. All right. Now I'm starting with the intro part. Okay, so the goal of the intro is really to bring us on the same knowledge foundation. It's really to help you guys understanding where we are and what's everything about this open source and proprietary software difference. And let's see how far we go with the knowledge part. In general, what do you see here in the background is a huge grid. It's actually the existing grid that we have today all around the world. It's the high voltage grid mapped and medium voltage grid mapped in OpenStreetMap. And based on what you see, it looks super meshed and complicated. And to actually make any sort of decision in this complex grid, we need some tools to do this planning. And what questions do we need to answer with such tools is how to operate the grid, how to invest here, how to regulate it, or even innovate it. And in the past, proprietary energy planning tools, they were really doing the job for that. They gave you answers to all those questions. And just to give you a background on how this works with proprietary software, like with Microsoft Word that you might have installed, you actually need to purchase for every program you use a single license, and you're not allowed to make changes. And in most cases, this fulfills the need. You actually also have really good support around that, and it's widely known. So that's equivalent in the planning industry. But you're like, once you start to change things, it's really difficult. Like you cannot make independent feature enhancement. That's really the job of your vendor. It also restricts collaboration, so you can only if your partner has also the same license of the same tool, you can collaborate somehow. Otherwise, there's no tool use collaboration, and in general, you can never, as I mentioned before, collaborate on the development itself. Like affordability is, especially for energy planning, a big problem. Like one license can cost up to $100,000. And like in case you need 5 to 10 licenses for your team, this really hinders scaling, and it's not affordable for everywhere around the world. And then there's also the aspect of transparency. Like some of the tools are considered as black box tools. They block transparency or reproducibility, hinder automation, and yeah, that's another thing we often hear causing troubles. We also have the aspect of digital sovereignty. Like that's a bigger point now in Europe, as I hear that quite often. It doesn't exist with proprietary tools. And for example, if you're fearing sanctions from some country, you actually, like in the worst case, have a blackout of your system. I mean, that's really the threat that you can have if you rely on the wrong partner. And open source, in contrast, is really about freedom. It's about collaboration. And what's really cool nowadays in many parts of the world, we rely on that already. Like be it automotive industry, like most cars are actually using open source software somewhere inside. Same for phones, like all Android phones, like they're all built on open source stack. Similar, I mean, like nuclear submarines, they represent really critical cases. Like they are partially run on open source software. So it's really on every aspect that you can imagine, you find open source software. And I just want to quickly introduce you on how this open source thing would work. Like in general, you have a open source repository. It's somewhere in the web. It's public. It has certain features, and you have a group of people called maintainers, and that can be really anybody, unless they they need to qualify for that. And that mission is really to enhance the tool and keep it stable and safe. Often, what you find there, there's not one central repository where you rely. Actually, what people do is they're creating their fully independent copy. We call it fork in the space. You sometimes develop their new features, and in our case as OET, we work here even public, and we have our own governance. Like if we don't agree with some of the public project decisions, we can decide ourselves in our repository. What's cool about that is we can really share and get features, and the most efficient way why we're usually contributing things back is because it's really benefiting our development speed. And yeah, we see that more and more coming. In the industry, there are also private and sometimes public forks. They have as we do, own features and their own governance, of course. But is it isolated? No. What happens in this open source version is that people can collaborate, they can partner up, they can push the next innovation step. And because we know roughly what's the foundation of those tools, we and others can really easily offer support around those open source tools. And because we're really loving this concept, our vision is to make open source based energy planning a standard by 2028. We have a lot of strategies on how to achieve that actually. That doesn't mean that proprietary software tools won't exist anymore, but it definitely moves in the direction that we have more existence of open source tools. And one question, and just handing over now to Bryn, one question that a lot of people have is, okay, there are 200 or more open source tools out there. How can I shortlist a couple of tools that I want to investigate closer. And that's really, from my part, for this initial part, and just handing over now to Bryn to introduce us this new app that we developed.
Yeah, thank you, Max. So we've developed the Open Energy Modeling Tool Tracker, or the OpenMod Tracker. You can see here, hopefully somebody can drop the link to this also in the chat. Here we showcase over 200 open source tools with which you can model energy systems in various ways and at various scales. Alongside each tool, we provide associated metrics, which we've gathered and we keep up to date automatically using public APIs. This includes an indication of tool popularity, how well it's being maintained, and how robust the community around a tool's development is. Most of these metrics are linked to each tool's hosted source code repository. This includes its activity over time, the number of people following or starring a repository, the number of code contributors and distribution of their contributions, the number of copies or forks of tools that exist, and the number of downloads of a tool last month, if it's been packaged and is available on at least one popular package index, such as Anaconda. You can use this dashboard to understand the breadth of available open source tools, to quickly access their documentation, and to filter them according to your preferences. You might only want tools that are being recently updated. Let's say in the last couple of months. And also have a package available to download and start using. We have one manually derived column in this table that you can see here, representing the tools, which for a subset of the most popular tools gives you a high-level understanding of the type of problem you can solve with them. At the moment, this includes production cost modeling, also known as dispatch modeling, power flow modeling, and capacity expansion modeling. So let's filter, say, on capacity expansion modeling and see what we're left with. The tools are currently ranked based on the number of stars the source code repository has. You may want to rank them differently, including based on a weighted combination of metrics. You could do that by adding your own scoring via a new column, and then you can adjust weightings accordingly. Finally, we've collected some information on the users interacting with these source code repositories. Cumulatively, over 14,000 unique users have interacted with at least one of the GitHub hosted tools. Based on the data they share publicly on GitHub, we've categorized them into user types, their affiliated organizations, and their home countries. Currently, 65% of users interacting remain elusive, usually because they have no information associated with them on GitHub. If you think you might be in the 65% and want to be represented here, do make sure to update your profile. Of the remaining users, like today's webinar, we see the lion's share linked to academics, followed by an even or so share of users from industry and the professional services. You can see a global spread of users, particularly those from the US, from Europe, and also from China. This is data about interactions across all tools. If there's one or a few tools that you want to dive deeper on, you can also choose them from the drop-down menu here. I'll finish by highlighting that this dashboard is still under active development. We have more features in the pipeline to make it increasingly useful to all, and we welcome everyone's feedback, whether you're one of the tool developers in the list or a current or prospective tool user. The project itself is open source and public, so you can even contribute directly on GitHub if there's anything you want to propose. With that, I will pass back to Max.
Thank you, Bryn. Thanks for launching this platform. Yeah, like now we are just starting with the panel discussion. So we have a couple of really great panelists on board. One is Boris Dolley from RTE, Nicolas Omont from Artelys, VP of Operations, and Alex Parzen from Linux Foundation Energy. Maybe can you show your faces? And like I can't see them yet. Or maybe just speak a moment to pop up. Boris, can you hear me?
Yes, I can hear you, and my
okay.
webcam is up and running, as I can see it on the screen. But I don't know if you have this image too.
Okay, now I can see that. So I guess like when we talk, then we actually pop up.
Okay.
So like the first task for all panelists would be to just describe your connection and your role in to open source in under 2 minutes. So please, Boris, maybe just start right away. Thank you.
Okay. Thank you so much, Maximilian, for this invitation. And to introduce myself very quickly, I'm leading the open source program office inside RTE, the French network transmission system operator at the very high voltage level. And to give you my background, I'm working in the direction of the research and development. And before that, during 25 years, I was an IT project developer, then manager.
Awesome. Nicolas, like, do you want to go next?
Yeah, so Nicolas Omont, Vice President of Operation at Artelys. I've been involved with the development of PowSyBl since more than 10 years now. Now Artelys is very much involved in selling support and maintenance services using PowSyBl modules. So that's quite important for the customers to have service providers that can provide services of as good quality as for proprietary software, especially in terms of support and maintenance of operational platforms.
Merci, Nicolas. And then we have Alex from LFE.
Yes. Hi, everybody. So I'm Alexander Parzen. So I've been at Linux Foundation Energy for over 2 years now. So Linux Foundation is so been around for a little bit longer, so 25 years. This is where you will find the project Linux. Actually, it started with that. Now it has expanded with now over more than 1,000 open source projects, such as Kubernetes, PyTorch in sectors like telecom, healthcare, finance, the movie industry. So LF Energy is actually one of the newest initiatives. It started about like now 7 years ago, and we have now in the energy sector over 30 projects, 70 members. And our annual event last week actually gathered over 250 participants. So which means that basically in this space we are really growing the open source ecosystem around energy very fast at a time when actually collaboration in this sector is more critical than ever.
Awesome. Yeah. I think, as you can see, like we have great panelists here, and yeah, like we're starting. So, like I thought about 4 themes that we discussed today a little bit through this panel. Like one is on adoption drivers. Why now? Another one is on like is open source ready for being mission ready, and then third point, or like we have a part on overcoming gaps and building the ecosystem. And then fourth, like how to get really started right away. Starting with the first part, you're like, why now? I think open source in general is not new. Alex, you mentioned like you had really success now with the events, and I think what we can all observe in the sector is this growing momentum. Like there's more and more happening in the recent years. But like the question is, why now? Like, why are grid operators, regulators, and so on paying really more attention nowadays around this topic? And then maybe just starting here as well with Boris, like from your perspective of the grid operator, what was driving RTE to actually start with open source? I mean, you really, I think, were one of the first grid operators moving this way. Yeah. Can you share your perspectives?
Yes. In few words, we were pretty lucky because in 2017, we were asked by the C-level to release in open source the code of the model of the energy planning that we use to enlighten power public to decide on the energy way for the energy transition to happen. So the start was directly at the top level for transparency purpose. So it begins with a kind of a momentum, our own momentum, enlightening public on the energy transition and being fully transparent on this mission. Then switching from evaluating more than switching from transparency to contribution, we decided to build the first start of an ecosystem, which was the very early project of Linux Foundation Energy with Linux Foundation Energy and Alliander at the time. We were in 2019 at this time. And building this ecosystem of how we can contribute together, exactly as you described in your first introduction, Maximilian, to open source. So that's how it happened. And to answer very quickly and let the floor to the other panelists, why open source now? We were kind of a pioneer in 2017, but now we're kind of a mainstream actor in open source, and we are very proud of this ecosystem of OET and LFE and Cresim and others that gather what we need to work on together. So the why open source now answer would be, from my point of view, because our industry is now software defined. And the automotive and the telecommunication was software defined before us. So it's time for our industry to shift from our own business units and business management of our ICT needs to a common one. And the best way to do that is open source.
Yeah, that's great. So, like as a summary, transparency was really driving you, and like you were really, I think, also, I mean, the proud pioneer, I guess. And yeah, like now the industry is just shifting. We need more and more software. Or like we have more and more software reliance and just need to figure that out. Like Nicola, in your case, you joined with the support of PowSyBl. Like what was driving you here, or like what's your perspective on this adoption point?
So open source is about cooperation. I mean, software has a cost, and then you've got to share it. So there are two schemes: either direct cooperation in open source project, and on the other extreme, proprietary software where cooperation goes through a vendor that provides licenses. And in both cases, the goal is to avoid redeveloping 1,000 times the same software that does the same thing. So why did it switch for European TSO? Why does it switches from proprietary to open source? That's a good question. The main thing is that it's possible because there is no competition on software by TSOs. So they can cooperate easily. Somehow it's not their key business, and they have the flexibility to do it. And somehow they do not rely on licenses of the software they develop for their revenues. So that's why it's possible. It's the same thing for Linux or Kubernetes. If you want, at the end, they have a cost. Most people use it for free, but then the people who finance it, that is mainly Google, Amazon, Facebook, they recover the money because the pie of the cloud services is increasing and they take a share of it. And that's why it works, and that's why they cooperate to make it work. So somehow, for TSOs, the same kind of business model is possible. And Artelys is just a catalyzer, an enabler, if you want. When the TSOs have decided to cooperate, they need a third party between them to ensure smooth cooperation and to provide support and services, because RT is able to provide support and services, but is not a vendor. So it's not its business to do it for the other TSOs. So at some point, that's something that is needed. And in addition, with the philosophy of the Linux Energy Foundation, the competition is promoted so that there can be many people providing services around a given software solution. So that's why I think it can work. And why now? Well, because it now works on par with proprietary software, especially for open load flow. So that's a big feedback I got last week from the Linux Foundation Energy. People tried it, and they said, okay, it works. So now what do we do? With the big investment we did, RT did, the Cornet program did, now we have a load flow and a security analysis that works on par with proprietary software. So the next step is adoption.
That's great to hear. Like Alex, like do you have any other perspectives on what was said here?
Yeah, I'll just add a few words just to take a little bit of higher view because I completely agree with that. That was what Boris and Nicolas said. I'd say that this debate about why now in the energy sector, if you're looking at virtually every other sector in the industry, services and everything, right now open source is really the modern and the common way to do software development. It has become like commonplace everywhere. And if you look at, for example, an industry that's very common to that's very similar to ours, which is the telecom industry, they've done this transformation over the last 10 years. Like in 2015, they were pretty much where we were with proprietary software, with IP and everything. And over the last 10 years, they've transitioned progressively to adopt a lot more open source software in things like routers or 5G or other things like that. And what they've seen is that it increases interoperability quite a bit. It makes time to market very much lower. It just allows standards like, for example, 5G or 6G would not exist without open source. And so basically, when you look at this, why now for the energy sector is exactly as Boris said, we're increasingly becoming a software-defined industry, so it makes sense to do open source. There is just there should not be any debate for this, and we're starting to see, as Nicolas said, all the benefits that it can use. As people are actually trying and they're becoming more comfortable with it, they see all the benefits. So the telecom industry took them 10 years, so it's going to take some time in there, but it's a shift, it's a transformation that is completely unavoidable because it just makes sense.
Yeah. So it seems like really other industries show that like this can work. It creates benefits, and then like now it's just the time for our nice energy industry to go the same path. Yeah, like just moving now to the next question. I think what's like actually like we're skipping one. Let's talk about this overcoming gaps and building the ecosystem. Like how important is that? And here I think probably not every tool now is perfect. And like it's also no exception for energy planning tools. but like the strength is really in the ecosystem, and we have a community of consultants, grid operators, and other users. How can we leverage that? How can we deal? How can we close the missing gaps, add support, and keep the ecosystem healthy? I think here actually the best one to start is probably Alex. What's your thought on it?
Yeah, I guess so. I mean, you explained that in your introduction. Open source software works because you build a community. You build a vibrant community. There are many actors that have a vetted interest in the tool you build. They make it part of the strategy and things like that. But what that means is, for open source to work, you need to have the strategic alignment. People need to invest in these open source tools as really part of their commercial business, and you also need to have some form of value creation. I mean, somehow, if you want to make it sustainable, there has to be some kind of products or services or anything new that you can sell. Once you've said that, there are very many ways to make open source software sustainable, and that's at the Linux Foundation. Really, what we're focusing on is this 1% of open source project that will actually become sustainable, that will scale, and that will become like commercial grade, industry grade software. We are aiming like at the Linux, at the Kubernetes, and PyTorch, all these things that are very large. And so what that means is, at the end of the day, when there are gaps, there have to be an ecosystem of consultants, vendors. There have to be an ecosystem of end users that are really like making this part of the core strategies. So, such as RTE or Artelys are actually a great example of this. And so Boris and Nicolas can tell you more from their perspective on how they're contributing to making all these tools actually sustainable and something that you can really rely on for your strategic needs.
Yeah, like on our, like from an OET perspective, I think what we just see is, or like one important aspect is money. We just really need money to finance developers, people that can actually enhance things, right? Because at the end, it's a developer adding something, maintaining it, improving things, and it needs money from public, private, and so on sources. I think now we have here different perspectives also from Boris and Nicola. I think like RTE is really committed. Like you really give everything. And how can we have more RTEs around?
Thank you so much for your kindness. Yes, what's missing, I think, at the first plan is the cultural shift from all of us. Regulators, TSOs, vendors, consultancy, and procurement inside all these layers, which means it's also a political question, at least for the European Commission, and the European Commission is completely aware of the importance of putting public procurement more either for research and development work or industrial at a commercial grade level solution on top of open source. And we have to found these open source layers inside the ecosystem of LF Energy and OET. So the cultural shift is, of course, a question of the chicken and the eggs. If no one jump in, the cultural shift won't happen. And we are speaking, a lot of people, Artelys, RTE, and other TSOs are now either adopting or contributing to this open source ecosystem, and contributing by specification from a functional point of view, or to the code as a maintainer. So, and sometimes as commercial support solution, like Artelys offers, and RTE International and many others. So I think that the most important thing is to demystify that other critical and risk-averse industries already done the paradigm shift and cultural shift. So it's just a question for us of demonstrating the evidence, sometimes axiom. Open source is a very good way for interoperability. And as a software-defined industry, now what we need is interoperability, transforming the legal code to software code. And this work, we should stop on what is eligible for that. We should stop to do it in each TSO, in each RCC. We need to make it together on top of open source and standards. And open source is nothing else than implementing standards.
Yeah. And, okay, then. So what you're saying is, like we are stronger the more we are in a way.
Yes.
And like the culture shift, or like I would say the awareness also is a big problem.
Yes.
Like a lot of people are just not having this awareness that hey, something like this exists and we can actually be part of it and we can grow together and so on. So maybe Nicolas, from your perspective, like when you speak with people, is everybody aware of open source?
No, definitively not. So for me, indeed, money is not the problem. I mean, proprietary software just costs a huge amount. TSOs have huge IT budgets, so money is here for operational software. So what we need is to be able to compete with proprietary software. So we need a cultural change, that's for sure. We need awareness for that. And I would say we need a little bit more. I mean, all TSOs are using Linux and Kubernetes now. None of them is contributing to it. So they are lucky users of something that came, a common good they got for free. So some actors are recovering money because they are very big and that they sell services, cloud services, I told you. That's why they pay for Linux, they pay for Kubernetes. But there is a bad habit of people of using something for free just because it exists, but they don't even think about contributing. This is not going to work like that for the software we are talking about today. This is software specific to the energy industry, so it has to be financed by the energy industry and not by anybody else. And so this is also something that should change. So I don't see there are so many technical gaps. They're going to be filled, but what is important is the organization. So we need to overcome the tragedy of commons. So that means that it's good to have RT being the first one, but then the other ones have to take their share. And if they are just using PowSyBl, well, at some point, even RT may say it's useless. They have been very persistent, and it was good because we now have some successes, but we need to continue and to make sure that every TSO takes its share. And there are quite simple ways to do that. It's not necessarily expensive. It's a bit more expensive to coordinate somewhat. It's a bit more slow. It's slower than when you do things alone, but you can go you can go way further even if you go a bit slower. And for that, the first point to change is in the IP and the public procurement system. So TSOs have to be aware that it's allowed to ask for open sources in their tenders. It's even allowed to ask for specific technology. So TSOs are allowed to ask for PowSyBl. They are allowed to ask for PyPSA in their tenders, in their public tenders. And that's what they should have in mind when awareness came at such a point that they are ready to use the technology. This should be in the public tenders to force it. And even if it's not to this point, we should have fair competition with proprietary software, and we should be allowed to reshare all the IP, all the development that we do for a given TSOs. We should be allowed to share it open source because this is the way for Artelys to be able to reuse it for another TSO. if I develop something around PowSyBl for a given TSO, and if the contract is done such that I cannot reuse it at another TSO, then it's lost for everybody.
We see that also quite frequently. Like IP protection is the standard, and you really often have to fight for like making this a little bit loose. But yeah, I think that's a good transition to actually the question of how do we get started? Like, is there anything you would recommend? I don't know, like Boris, how did RTE start really?
Mm-hmm. Yeah, I think that RTE started, as I mentioned at the first point, with a momentum. And now I think it's the momentum for the global energy transition to happen. So if you are a public interest company, social welfare, you want to take care about these things, you should consider that the public money should transcript the public expectation into public code. And this is where everything starts. When you are concerned that it's a viable model for other industries, there is no reason why it wouldn't work for our industry, which is energy. This is the completion of the cultural shift. But to be very concrete, how to get started? Just consider how your model of producing software for your core business works. So you often have a subcontractor will develop what you need, and you have a tender for that. You will do the procurement. So maybe the first stage is to try, do proof of concept, and then compare the result of your proof of concept based on open source solution, and then compare with your legacy. Compare the results. And you will see that it's not a theoretical scenario I'm describing. It's a concrete testimony from 50 Hertz last week in the LF Energy Summit. On stage, the person in charge of the ICT for operation in the control room, he mentioned to everyone here, we're speaking about more than 380 people in the room, to say that they compared their legacy to possible results for security analysis on the network. And guess what? It was quite the same. And sometimes they were questioning the legacy if it's possible to make evolution on this precise topic and have more fine-tuned results. So begin by being curious. Compare what you can expect from open source compared to your legacy is the first thing. And then after you tried, just ask to your procurement how we can invite newcomers in our tenders in order to get out of this vendor lock-in we are in. If you are ready to make a change inside your methodology and tooling for core business, and then do the procurement and ask for the solution you have assessed in open source, because you are not able in closed source to say, I want this product. But in open source, you are allowed to do, I want this product and I want this community, because every private actor of the sector actor will be able to join the community. So it's, I think, try and then buy with the procurement.
Like just a reminder also for the audience, like I see already a couple of nice questions. Like get your questions ready, like we are moving in a moment to them. Alex, like maybe from a little more abstract version, like what's needed for getting started? I mean, or like, I think you see a lot of people starting and then probably they come with the questions to you on like how to actually start. Like, what's your tip that you're giving them?
Yeah, I mean, I'll be actually very concrete. Is a good place to start would be the list of projects that we already have. and that are following the standards that you find in the Linux, Kubernetes, PyTorch. They have the same DNA, and we're working very hard to make them grow so that we can do that. There are also other kind of resources, like for example, if you like to set up an OSPO, which will be a question as you do your journey. Of course, there is something that's called the to-do group that can help you start it, and the organization within LF Energy. Those who have OSPOs there, they would be very, very happy to help you. I said that up, as Boris said, and then perhaps the last thing is, as was said by Nicolas and Boris, you don't have to have software developers in-house to do open source. I mean, let me also demystify this. Again, you can procure. You can procure open source software. This is the cultural shift, but this is something that is actually very common in many other industries. So this is also a good place to start. Look at how you can procure some of the great open source projects out there and make it part of your procurement requirements, because then you know exactly what you're getting, and you've got all the freedom. It's free as in freedom. You get the freedom to choose exactly what you buy and what you can get with it, and how you can make it evolve, and how you can make it change and everything. Those are kind of like tips and resources to get you started. And at LF Energy, it's actually our job to help organization navigate this.
Yeah. And hopefully we hear later also a little bit more from like this different organizations really that adopted various open source projects on how they started, and I guess we will hear like a lot from them. And yeah, also thanks to all the work at LF Energy, like really creating a momentum and pushing the boundaries here. I would say let's go maybe to the audience questions. Like we had a couple of them. Bryn, I think screened some of them. Yeah, Bryn, like, do you have a question for us?
Yeah, so I've got a few questions coming in from the YouTube stream. The first one is, how would you imagine, or how you're expecting that consulting businesses would contribute to this ecosystem? Because obviously you're talking now, I guess, from the perspective of utilities or a TSO sort of level. But what about those in the middle who are providing consulting services using these sorts of tools?
Who wants to answer that?
Right.
Expectations for consultancies, Nicolas, I guess.
But the business of Artelys around open source is twofold. First, we are, as I told you, developing as vendors or subcontractors for TSOs, and then we are using software to perform studies. So indeed, the fact that at Artelys we have always been focused on mastering the tools that we are using for studies. So, for example, last year we used PowSyBl metrics to do a study for ASC on how much wind capacity could be added to the system if using grid enhancing technologies. So that's typically where consulting can contribute, either when you do development, either when you are using it. Well, you can promote it, and then also use it in a Horizon Europe project or R&D projects, where you can develop new proof of concept or new features.
I think from our perspective, I guess not a you have to situation. Like you actually don't have to contribute back. But actually sometimes it's just more economical. It saves you down the line all this testing, like if you develop your own feature, you constantly need to test that with what's happening in the open source project. So sometimes it's just easier to push that to open source, but like people don't have to. At least like that's in our opinion. But like Alex, do you feel similar, or like how many in some of the successful open source projects, like is everybody contributing back, or like what's the percentage?
No, I don't say. Yeah, I don't think everybody is contributing back. But basically, I think that the mindset that you need to change is a successful open source project is actually very welcoming to outside contribution. That's the other thing. If you want people to contribute, make your code very well documented, make your roadmap very clear, your architecture very clear, and tell people. I mean, open issues. Get people to have events, have a community, have all these kind of things that just make it very easy for people if they're making an improvement or a change to the software for their own needs. It should be extremely easy for them to actually put it back. And then there is a community, there is a governance, and actually the community will actually take the contribution and merge it with the actual with the main software. And so that I think that's how you get a lot of different contribution. If you're talking about PyTorch, so that which is now one of the leading AI toolbox in there. Last year they had more than 3,000 or 4,000 organizations contributing to it. And so you can achieve that, but basically you have to make it very welcoming and very well governed, very well documented, and very easy, very modular, so that people you make it easy for them to contribute to what used to be your code, but now it's not your code anymore. It's becoming something much more.
Okay, that makes sense. Like make things easy for developers, so you get more contributions, increase the share of contributions. And Bryn, like did we get a more questions there?
So the next one is a bit different. It's about interoperability, and I know that this was mentioned already by a few of you as one of the benefits of open source in other sort of domains, but how do you handle the problem of interoperability, particularly when you're looking at tools that maybe one does production cost modeling and one does power flow modeling? How do you do it in a more seamless manner? Can you imagine, I guess, a data standard or something like that in this domain?
I'll take this. I'll give it a try to this very important question. When you are doing open source, when I say that, either adopting open source project or contributing to the one you choose to contribute, you are not completely active for interoperability. The first step, because you join the open source journey, and of course it's necessary. But when you are leading a roadmap for a project / a product, which is open source, you will have to always think about interoperability. By that, let's take the example of PowSyBl, Power System Blocks. It's a set of libraries, so it's kind of a set of products, and each product aims, and Alice will present that just later, but each time we wonder if what we are doing is as good as the state of arts for drawing a network, for converting data to a data format to another data. Is the format a standard? Is the format an emerging standard? De facto standard. Is the format proprietary? Are we allowed to not reverse engineering, but read the doc and do the capacity to also interact with that? Always ask yourself, my product in an ecosystem, is it clear from a technical stance and a documentation point of view? is both sides are designed to be interoperable. Open source is a very good way to have this reflex. And the last thing I really would like to mention about interoperability in open source, that standards in the world were created for security reasons in a market, but also for interoperability. But guess what? When the vendors come to the place, they will, of course, do their own flavor of the interpretation of the standards, because there is always an interpretation of the standards. So the interoperability will have kind of barriers, not always voluntary landed barriers, but there will be barriers. When you go to open source, you design the interpretation of the rule, of the standard, and you put it in line of code, which is the truth, and the only one truth. So here, the open source is a very, very good condition to be interoperable. I'll stop that because maybe Alex and Nicolas will complete.
I would say what you say. I mean, PowSyBl was started more or less together with the adoption of CGMES. So PowSyBl has always had a good support of CGMES. I mean, it does not aim to be the only implementation of load flow based on CGMES, but the fact that it is open source, and the fact that everybody can test it and see what it gives, what the result it gives in all kinds of specific situations, gives more depth to what you can do. So the first step is to describe the format, then is to have guidelines, but at some point, even these two steps are not enough. And having a reference implementation, even if from other perspective it is not what you want to use, is a very good help for adoption.
Okay, sorry to interrupt. I'm just seeing that we're actually running on time. Okay, I think big takeaways. We see a big momentum. There are more and more people joining to close the gaps. We just need a good ecosystem. We need money to close it somehow, and each of the players being involved there are important to contribute back. We can make life a little bit easier in this context, and yeah, there are several pathways to start right away. But I think now in the next 6 lightning talks, we hear much more. And the first one, first of all, thanks to all the panelists here for contributing. It was really nice to have you. And now we are starting with a clap for you first. And Christos is now the next speaker, telling us a little bit about the European Energy Regulator and how they started the open source journey and why, I guess. But let's hear from Christos.
Hi. Good afternoon to everyone. I'm trying to share my slides, but I cannot see them at the moment. So give me a second to retry to open the file. Okay. Right. So I hope you can see. I will try also to put it on presentation mode, which I hope it works. If somebody can confirm, because I cannot see anything.
We can't see the presentation mode, so it's with the side panel, but everything is readable.
Okay, let's continue in the interest of time with this version, and I hope it's visible for everyone. So. First of all, good afternoon or good morning to everyone, wherever you are. I don't know where people are joining us from. My name is Christos Kolokathis, and I am the team leader of the Flexibility and Resilience team within the Energy System Needs Department of ACER, the Agency for the Cooperation of Energy Regulators. Our department is basically involved in a lot of the planning type of assessments across Europe, like the 10-year Network Development Plan and the European Resource Adequacy Assessment. So I will tell you a little bit today about a new project that we're working on, and I have a couple of slides. And I will start with a little bit of the context on this project. So as some of you might be aware, the recently approved electricity market design reform put an increased focus on the integration of renewables in the system by establishing flexibility assessments. And these flexibility assessments will happen at the national and European level. And the goal of these is essentially to estimate what are the flexibility gaps in order to integrate more renewables in the system. So I will not go through the process to get to these assessments. You can see this on the graph on the slide, on the right-hand side graph. But essentially, the legislation also gave the responsibility to ACER to undertake a pan-European flexibility needs assessment. And in this context, we had to make a decision as an organization about the model, the tool we would use to perform this assessment. So fast forward to our decision, we have opted to use an open source modeling tool, the PyPSA AUR modeling tool that I expect a lot of you are quite familiar with. And I will talk to you in the next few minutes through the main drivers and reasons that we opted for this tool. So for the first one, and I think it's something that was highlighted repeatedly by the panelists earlier, is transparency. We think, it is highly important for us that whatever we are going to produce, that will be available to the community, available for stakeholders to be able to replicate the analysis, or do their own analysis, or improve what we have performed. And I think there are further, let's say, benefits in this. There is a benefit in the sense that also what stakeholders do can help us improve our own assessment by providing us feedback, for example, on the analysis that we're doing, but also it can build trust across the sector that what we have performed is fit for purpose, or how to improve it going forward. So this is, let's say, probably the main driver for our choice for the open source model. In addition to that, when we were examining the different models that were, let's say, available, PyPSA appealed to us because of the technical features that the model included already. So we identified that it was providing a robust starting point based on which we could build further on and produce a fit for purpose assessment for what we needed to do. Linked to that, another important aspect for our choice was that the model is highly adaptable. So that could, let's say, ensure that if we wanted to use this model for other purposes, to underpin other analysis or other decisions within the organization, it was feasible to do it. And we weren't, let's say, developing something that would be fit only for one case study. A final and very important driver, let's say, for our choice was the let's say, the broad, the vibrant community that was using the PyPSA tool. So the tool is used by system operators, international organizations like the IEA, but also academia and other stakeholders. And this was important not only because we knew there was a community out there that could collaborate closely on the model, but also it offered the reassurance to us that its development would be impartial, that its development, let's say, would gather several inputs, several perspectives when it was happening. As I have probably alluded already, our intention is to make this model publicly available once we release our first assessment, which is meant to happen in July 2027. Again, so that we can contribute back to the community, and we can also, let's say, kickstart potential collaborations going forward. This is, of course, with the caveat of any confidential information and data that goes in the model that we would be unable to share. I would close with 2-3 final thoughts, reflections on areas where we see scope for improvement to make, let's say, the use of open source models broader across the sector. And some of these points were already expressed by the panelists earlier. So the first area for us is that of usability, and I would point particularly here to user-friendly interfaces. If we want to make these models accessible to a wide variety of stakeholders, we think it's important to make them accessible to people that are not necessarily model experts. So this would be one area. A second area would be around data completeness and interoperability. I think there was quite a bit of discussion on interoperability, but perhaps on completeness, what we also see is that the data is not necessarily always out there, and it's not necessarily always explained, understandable for everyone. A final point here that, let's say, we are increasingly coming across while we are developing this assessment is about efficiency, is about computational complexity. And here, I think the main point is that when these models are being developed, there needs to be perhaps a greater, let's say, appreciation from the outset about let's say, how to improve efficiency, not only from an optimization point of view, but across the entire architecture of the model. And I realize that I'm a bit over time, so I will stop here.
Thanks, Christos. Yeah, like just a reminder for the other speakers, like we have around 6 minutes for your talk and 4 minutes for Q&As. Meaning, okay, Christos, we ate a little bit of your Q&A time, but let's maybe just have one question from the audience then. Bryn, like, what's the most interesting one to you?
Maybe a slightly controversial one. Why has ACER selected PyPSA and not Artelys?
Right. I mean, again, I will not go through the details of, let's say, our choice, but as I explained earlier, like the main drivers, let's say the main reasons that we chose PyPSA was, okay, of course, open source, which both models let's say comply with. It is about the modeling features. It's also about the community. And I think what was, at least for me, what was exciting, let's say, looking into PyPSA last year was how its usage was, let's say, increasing across the sector. So that was really providing a significant degree of comfort that, you know, something good is happening there. There is something really valuable about this model if all these, let's say, high-profile organizations are selecting it.
Awesome. Thanks, Christos. Like, by the way, we got a lot of hearts and thumbs up during your talk. So we're like the crowd on YouTube loves you.
That's great to hear.
Then we have the next speaker from TransnetBW. That's Massimo Mosa. Massimo, can you share your screen?
Yeah, just a second. So let me know if you can see now.
Yes. Full screen, perfect.
All right. So also welcome to everybody. Also from my side, my name is Massimo Mosa from TransnetBW, one of the European TSO. And to my person, I am at TransnetBW since 5 years. Before I was active in the energy research, and since last year, team lead of our team energy systems. And so we have also something to tell about PyPSA in continuation to the previous speakers. And here the focus of my talk will be on the advanced modeling frameworks for long-term energy system planning. So maybe before I go into the details, with some few words about TransnetBW. As I said, one of the 4 TSO in Germany. And maybe one detail about our goal and vision is that to operate, maintain, and design the energy or power network. And this is also, let's say, defined by law. It's very important, and also important to notice on economically reasonable parameters. Well, we are responsible for the region of the southwestern of Germany. So, here, when we trying to answer the question why we started with PyPSA, as I already mentioned, I think it goes back before my time at Transnet, was 2018-19, in which the question was how to find a solution, also for the tools, which can couple on the one time the climate neutrality goals on the one side, and also the quite long planning and building times for such large projects as you are involved in the new interlinkages between, for example, northern and southern Germany. And so at that time, as we introduced PyPSA, or my colleagues, the goals from the German policy were not up to climate neutrality. So, but as we need a long-term planning in order to planning in a cost-optimal way, we decided to introduce one energy system model, and our choice goes to PyPSA. Based on this open source version, I have to make an all explanation here. We created our own branch, and we made some extra development in order to fit the model to our needs. 3 examples here, how is the main usage of the tool. As I mentioned, we created 3 studies, strategic studies, which are separated from the mandatory legally processes we are involved. You find the links of the studies on the bottom here on the slide. Please go and find more detail on that. I think the main idea is here is to identify with this kind of model, which is very fit for purpose to provide answer to blind spots. And this, for us, is very important to create a robust network planning. Here's some more detail about how we introduce PyPSA in our tool chain. In the end, our focus of our analysis is on the planning of the concrete interlinkages in the power sector. In order to get there, and on the consideration on all the policy goals and the sector coupling, we have to create a model change which is able to put light on these different aspects. It's a complex problem. And we came up with this solution. We implemented in the framework of the last project, which is called Adequacy 2050. The focus there was on the long-term perspective in the security of supply sector. And here we have 3 pillars. One of them, on the left side, is PyPSA, our, let's say, version of PyPSA, which is used to create or to provide answer according to the macroeconomic optima regard to capacity. We have a middle tool, market model. The last 2 are proprietary for the time being. Let's see what's happening in the future. and which is used to determine, for example, energy not served or more detailed pattern in the power sectors. And the last one is very typical for TSO in order to provide detailed calculation for the electricity network. Here you can see also some examples in them with regard to the last project, and you can also find here the link to discover more results in an interactive way. And I
Massimo,
think,
yes. Perfect. You're just ending in time.
Okay. Yeah,
that's great. So people are probably typing up questions. One that I have for you that I'm really interested about, like, how did the story at TransnetBW start actually? How did management decide, okay, instead of using for your long-term planning purposes, you like an open source stack instead of something, I don't know, what you already have?
Yeah, I think it is related to with the mismatch between the historic policy goals, which in the back to 1919 were not as the current one, so up to climate neutrality in 2045 for Germany. This current goal were not existing at that time. And we are TSO and other TSO as well in Germany, and not only, were confronted with the question how to decide in a reasonable, rational way for these huge investments in the long term. And so we, at that time, we lack of a tool which was able to look behind the policy goal. And after looking for several solutions, we came up with the energy system models, and then among them PyPSA.
Awesome. Just in a matter of time, or maybe you have a short answer to that. Like another question on YouTube: do you perform back tests of your dispatch model to ensure robustness? Like your one-line answer.
Well, we do, but it's an ongoing and demanding process.
Okay, very demanding. Oh no, that's great to hear. Then thanks, Massimo. Thank you so much for showing up here and sharing your thoughts. I also saw some being shared. Then the next speaker comes now from Canada. We have Ganesh from Canada. The stage is yours. And we see your full screen. Perfect. Everything's fine.
Thank you, Max, and thank you, everyone. So I guess I'm going to take you all to the other side of the Atlantic now. Good morning, good afternoon, good evening, everyone. I am Ganesh Dolley from the Canadia Energy Regulator, or the CER. The CER is Canada's federal energy regulator with a dual mandate. First, we regulate federally regulated energy transportation infrastructure, such as pipelines and power lines. And second, we deliver on our energy information mandate by providing timely and relevant energy data and analysis to Canadians. Today, I'll share how we used open source modeling tools, specifically PyPSA, in delivering that energy information mandate, enhancing our long-term energy outlooks for Canada through our Energy Future series. So Energy Future series, or Canada's Energy Future series, or the EF series, is our CER's flagship energy information publication. It explores how energy supply and demand might evolve over the long term, and it is widely used by decision makers and analysts across government, industry, and academia in Canada, and then hopefully in internationally as well. The latest edition, or we published the last version in 2023, or the EF 2023. It is especially significant. It's very special to us. It's our first model scenarios. That's where we first we modeled a future where Canada reaches net zero emissions by 2050. These projections, so basically, I want to say this is not only electricity projections. This is like all energy sources, all economic sectors. And then these projections are built using a suite of interconnected energy system models. And then here I am actually showing our modeling system. It is basically our modeling system basically comprised of 7 models, each assessing different aspects of the energy system, whether it is conventional energy supply or energy demand systems, or different aspects of the economy. So we have individual modules in our interconnected energy system analysis system to kind of project energy supply and demand in Canada. And as many of you know, it is a big country. It is like 13 provinces and territories, which are kind of very different in terms of resource supply, existing energy infrastructure, and so on. And then we are trying to model all those economic and energy interactions. One of the core components of this modeling system is actually our energy supply model, which we completely redesigned in 2021. We built the model, which what we call PyPSA CAN, using the open source PyPSA framework, and then we actually customized that significantly with LinoPy to reflect Canadian conditions. In essence, it is actually a combined. The PyPSA CAN part is actually a capacity expansion and high resolution dispatch model. This module interacts seamlessly with other models in the EF system, like the demand projection system, the kind of like orange model, orange block, and then macroeconomic models, and also all the fuel supply models, allowing us to seamlessly model Canada's energy system. Now, if so here I'm actually showing kind of like a spatial representation of our model or PyPSA CAN. It basically represents 13 provinces and territories of Canada, modeling each jurisdiction's electricity supply system, capturing regional differences in electricity demand, demographic conditions, existing generation, and interregional transmission system, as well as different resource conditions. Like I said, it is a big country, it is a big region, and then we were able to represent all of that seamlessly using the model we built. This spatial detail is essential for us to produce robust electricity supply projections in our Outlook or in the EF series. And the model outputs are typically, what in the electricity outputs, different generation technology build-outs, transmission flows, and capacity expansions, and so on. All are critical insights that are needed to provide long-term projections. Our latest publication, like I said, EF 2023, it shows a future where cleaner technologies, especially wind, playing a dominant role in Canada's electricity generation. What I want to show here is we have all that information, all our modeling results, whether it is electricity or other fuels, are all published on our webpage, and a link to the tool is actually available on the program agenda, which you can access. And then our experience,
like
maybe
yeah,
I'm going to conclude.
Like just 30 seconds. Yep, perfect.
Yeah, so our modeling framework, benefited enormously from PyPSA, LinoPy, and also I should mention Artelys as well, all come from the same family, that allows the flexibility of those tools, allow us to develop, very robust electricity supply system, supply projection system, and by incorporating very complex operational and policy requirements, and then integrate seamlessly with our rest of our modeling system. So in closing, open closing tools like PyPSA, is more than a technical upgrade to us. It is a step towards a very transparent and inclusive, impactful energy analysis. So with that, thank you for listening to my thoughts. Yeah, I'll take any questions you have.
So thank you, Ganesh. So, Bryn, can you help me a little bit with the questions? Like, I'm getting now confused because there's so many things floating around.
I think the main question coming in, or the main question that's come in, is around how user-friendly is the bridge between medium-term and short-term dispatch. I believe this is for you rather than from the previous speaker, particularly related to hydro storage optimization.
Yeah, so it is. It is not. At the moment, it is not as flexible as we want it to be, but I think that's something we have as like, the next step, the next future work, make it a bit of a workflow. I think I had a note about it in my previous slide. So we are working on right now as a next step is, that streamline workflow management. So it is not just the capacity expansion versus dispatch model, which is also quite complex, but remember we have like another 7 models which we have to interact with. So we do need to, we have to develop, we have like some workaround set up. It's not as flexible we want it to be, but we get by. Like it is flexible enough for us to get our work done. Yeah, but good question, and then that is definitely something we are working on as a next step. Yeah.
Maybe Ganesh, like in relationship to one of the panel points, what's your role in the ecosystem? Like what's your experience within the ecosystem, and what's their position here on your side?
So if by ecosystem, did you mean Max, like a PyPSA ecosystem, or?
Correct, or like what role? Like, are there any expectations? Did you feel pressured to do anything or to contribute or something? Yeah.
No, not really. I haven't. There's always, like for example, I think I also mentioned we are sort of started conversations, collaborations with like a PyPSA USA team. Knowledge exchange and then experience exchange. So at the moment we haven't, and then also there's always questions and then requests coming from like other parties within Canada for sure. So we are accommodating them as they come. But the key output, the key result of our work is mainly the outlooks like projections we provide, which get used by like a lot of analysts and decision makers in the country.
Thanks, Ganesh. And yeah, like Canada is really big on open source. Like I think it's one of the, I would say, leading countries like pushing in that direction. So really happy to see that. Yeah, like now actually we have to move now. Thanks, Ganesh, also for the talk. We have to move now to the possible side. We have the first talk from Alice, talking a little bit more about what's going on at RTE.
Yes, hello, can you hear me?
Yes, clearly.
Yes, okay. Hi, I cannot currently display the slides, so I don't know if you have the access to this.
I think Charlotte has the backup.
Thank you. So yeah, about PowSyBl. So PowSyBl is an open source library to modelize power system blocks. It has its own internal model that is called the IIDM, and is here to be able to import a lot of different kind of formats modelizing the power system grid. And it's currently developed with a lot of collaborative work with like Artelys or SoftLab and AIA, for instance. And it is also already used on some products like Chorizo Institute. In the second slide, we have a general presentation because with PowSyBl we can model the power system blocks, but we also can run simulations and have a visualization of network. It is written with a lot of modularity. It's a very modular library, so you can use different. You can use it for different use cases, like running optimize power flow, like load flow, security analysis, sensitivity analysis. We also have some work about short circuit calculations, and there also are we can also, as I said, visualize the network visualize the network. Sorry. About the technology, it is mainly used mainly developed in Java, but we also have binding with Python, and we are working on Julia technology to improve our polyvalence, and Python is mainly used for a lot of quick realization. I can present you more in general in a more detailed view in the next slide how it works. So as I said, there is an internal model, the IIDM, which is the model in which the different formats can be converted, like CGMES, UCTE, or other proprietary formats like Power Factory or Mad Power. And thanks to this internal model, then we can use all the simulation APIs that can also be implemented by proprietary utils. So as I already said, we can launch security analysis, power flow, optimization, power flow. And there is also the visualization part to display networks. So as I said, it's very modular, so we can choose to load only the modules that we are interested in to be able to be more efficient and as light as possible for each use case. I'm really sorry about this quick presentation, because due to some strikes in France, I have had to be on my way to have a train, but I'm available for any question if you have some.
Awesome. Thank you, Alice. And yeah, sorry to hear about the strikes. I'm sure that's currently disrupting a lot in France. Yeah, are there any questions from the audience?
I have one about sort of the setup of PowSyBl, that it's written in Java with Python and Julia bindings. Have you come across any issues in terms of community engagement and external contributions due to it being written in Java, which I guess has a relatively smaller pool of possible contributors compared to, say, Python?
Sorry. Yeah, sorry. Can you rephrase just the end? I couldn't hear.
At least I think the question is if the fact that it is in Java is an issue because it reduces the pools of possible contributors.
Yeah. Yes, we also look for contributors in Python, but yeah, Java is more of a big. It's more used for big projects, so not everyone can contribute to it, I think. But it's still we have some contributors. So I don't know what you think that you, for instance, you would be more stopped by the technology for now to contribute.
Awesome. Nicolas, yeah.
Yeah, if I can. So really the goal is to have operational software. So we need enterprise grade software. And so when you speak with IT people, they are happy to have Java. It's easier to integrate with the remaining part of the applications, which is usually developed in Java. And then they have all the tools for cybersecurity because they can have the bill of materials. They have all the tools to have trackers to know in which of the dependency you have bugs or cybersecurity issues, and they can ask the vendors to correct them. So it's still Python is good, and you have many more people that are able to do it. But first, not every Python scripter is a Python developer that can code into something that's going to last for 10 years, that needs to be modular, that needs to be well tested with unit tests. We should not. We still need to do it in Java for these reasons, because we really want industrial grade software that will be accepted by the most stringent rules of deployment. And then, of course, we made the Python binding so that all the Python people can do scripts for studies, but some more code that can be that's not going to be maintained for 10 years. Most of the time, the Python scripts are used for a study or for short-term needs or by users that do not intend to produce quality code, just to intend to do code for themselves or for given purposes, but or for proof of concepts. But that's not going to last for 10 or 15 years like something that is deployed in a control room.
Thanks, Nicolas. Thank you for the talk, Alice. Thanks, Nicolas, for also answering a couple of those questions. Like now we actually have the next talk from Artelys, from Federico, who's sharing a little bit more about their work.
Yep, hello. 1 second, let me share my screen. Can you see my screen?
Yeah, full screen, perfect. Thank you.
As you were mentioning, I'm going to present the role of Artelys and our business as service providers around PowSyBl. So first of all, for those who haven't met us, we are a company that specializes in consultancy services, software solutions, mainly focused on optimization, modeling, and simulation, and we have a big part of our activities in energy, where we offer, as you can see, some our suite of software such as Artelys Crystal, some solvers, high-performance solvers for big nonlinear problems such as Artelys Nitro. But also we have an offer based on open source components, where the service we provide is more on developing new tools, on helping develop new tools, and or maintaining and providing support to those tools. As you were mentioning, PowSyBl is what we are focusing on today. PowSyBl is built, as some of my colleagues before have presented, as a modular architecture. So the idea is for it to be blocks, not to be a full application. So in a way that you can pick the codes, the blocks that you need for the functionalities that you need or for the performance that you need, and integrate them into your platform, into your applications to provide services in a way that allows the customer or the owner of those applications to really have freedom in how they work. Because by being modular, you can pick and choose not only from the PowSyBl library, but if you want to test new tools, if you want to develop new tools, then this modular architecture lends itself very well to growing those applications. So applications that will be future-proofed thanks to the development. Inside PowSyBl, there are many PowSyBl read computations or processes that you can carry out, such as power flows, all the way from very simple, fast DC, highly optimized DC power flows, where you can run thousands of simulations on a laptop on a big grid, all the way to the more complex full AC power flow, or even AC OPFs, where you can take optimize big power networks. And one of the strengths, as many have mentioned before, is that PowSyBl has been always in the core of the coordination of the European grid. So it communicates very well with all of the formats that are used to coordinate the processes around Europe. So with SIMCGMES, we recently, some of my colleagues were in a conference in Germany where they received very, very good feedback from TSOs, mentioning that PowSyBl is one of the best, if not the best, converter for SIMCGMES, making it a very good tool to be able to operate this coordination, this complex coordination between TSOs, regional coordination centers, TSOs and DSOs, or even internally within the different TSO processes. It's also very user-friendly, so it's not only an industrial tool that can be implemented inside the big applications, but it has a Python interface. It has PyPSA, where you can use it, as Nicolas mentioned, to run quick studies, quick scripts, to perform the services you want to provide. Finally, it's an enterprise-grade software. The governance from the Linux Foundation gives us a lot of credibility, but also we do regular security audits where all of the information is public. So the people that have this software implemented in mission-critical systems, in control rooms or things like that, they know that it's a safe system that is developed to a very high standard. For example, some of the functionalities that are available. These are just a few of the functionalities we have. For long-term studies, there is metrics, where the main attractiveness of this tool is that it allows you to do long-term planning of your grid, but not only taking into account conventional technologies, but GETs. So these new technologies that are appearing or are being implemented in the grid, such as batteries, such as artificial intelligence for controlling or managing your grid. And it's a very high performance tool where you can run thousands, hundreds of scenarios on simple hardware to get results that give you very good insights into how to plan your operation. Then we have Open Load Flow, which is the one that is in the control rooms of some of the RCC, of the regional coordination centers in Europe, running critical processes such as the European merging function, where the different TSOs supply their grid models, and we build a common grid model so that the security can be guaranteed and can be coordinated. And finally, OpenRAW. This is more on the optimization of how to operate a grid. So it manages a wide set of actions that you can do on the grid and how to optimize them to get the most capacity you can outside from the grid you already have, to optimize or to reduce congestions or to use it to the maximum level. I would like to show this presentation, this slide. It's from 2024. This is when I joined Artelys, and it looked like this. We started with RTE, where we were contractors and helping them develop this internal tool, which then became open source. Then we used it to tender for Cornet, to participate in the Cornet project as the load flow and security analysis providers. And when I joined, it looked like this. There was a roadmap on what other clients could we get. And now, almost exactly 1 year after that, we can see it has been growing very quickly. We are now working with other RCCs, with other regional coordination centers. So the community is growing very quickly, and these clients are clients that are very mature, that they need enterprise-grade software, and that they are willing to cooperate because they understand that, well, one of their roles they have is to be able to coordinate the grid in Europe. So if you have common tools or common grounds where you can share the information, the processes, and the governance, then this provides a very good advantage, or a very good way to manage your tools. And then finally, to keep it short, some of my colleagues mentioned before the challenges when a client is procuring software. Usually when you see that there is a provider that has a very good functionality that only they can provide, then they have a lot of negotiating power, where they can, the service level becomes part of that negotiating. but open source because different service providers can provide support to the same application, to the same compute modules, then it becomes highly competitive. And the way we as Artelys try to compete in that advantage is by providing a very high level of support. We provide a full level 3 support on our PowSyBl modules as if they were proprietary software. If needed, we have teams that are 24/7 available to the clients to solve issues.
Federico, like just to inform you, like we are eating already up the Q&A time. As you wish.
We can go for questions. I think that's.
All right. Any final words from? Actually, like we got a couple of nice questions. Like on Yves was asking if like this crystal grid future part, is this also open source?
You go, Nicolas.
So no, Artelys Crystal Supergrid is not open source. It's a proprietary software that we develop with licenses. So the data model is open source because it's heavily linked with the Metis project, for which you can find data on some data on the internet. However, currently, PowSyBl grid computation modules are being integrated into Artelys Crystal Supergrid in order to have a tool chain that can cover both zonal studies and nodal studies in one tool. So indeed, that's I mean, somehow the important point for Artelys is to find a sustainable model. When it is proprietary, it is, and when it is open source, it is. So that's why we think that it's very good, for example, that PowSyBl has an MPLv2 license that is non-contaminating, but that forces the redistribution of modification to PowSyBl, because we think that's a good trade-off to both to foster open source and to make it possible to live with together with proprietary software.
And Maximilian, can I add a few things? Do you have time? Yes. Thank you. Yeah, 1 minute. What we're showing here is very important. What Nicolas described is a question of viability of open source model. Here we are in an open source model. We are not in an open core model. What is the difference? The difference for the open core model is that some vendors has bait and they fish big fishes with the bait, and the bait is called open source. But behind this open source product, there is only one player who interact with the code, lead the roadmap, and do the contribution to this code. And then they sell on top of that added value software, exactly as Nicolas mentioned for the part of the proprietary software of Artelys. But the difference here is that Artelys and the other folks of the community do play the game by the rules of contributing to a collective community. So here we're in a very interesting business model, and it's a win-win situation. RTE gives up the IP because we are not a software company, but if software company can play this game of open source, contributing and give back to us what we invest in, we have a very positive return on investment from the point of view of RTE, and Artelys has a potential to grow. So this is a very nice win-win situation.
Yeah. Thank you, Boris, for the comment. Thanks, Federico and Nicola, for the presentation and question answering. We actually now starting with Vaiko's presentation from Baltic RCC. So also, like it was shown a little bit on Federico's presentation, Vaiko, it's your stage now.
Give me 1 second. I'll try to get the picture as well to look nice. So, hi. Right. So maybe works well. Good. So I'll try to show our journey, maybe how we started, where we are. So let's start with who we are. So we are one of the regional coordination centers. So this is also what RCC term means. This is a entity that was established based on the European regulation, and the main target of this RCCs is to do exactly what the name says: coordinate information of their owners, which are the TSOs. Which means that what we do, we basically take the TSO data information, on top of that add value, and then give that value back to the TSO so that they can do better decisions in the operations level. I also shared here our GitHub page, which is basically better than our homepage, because there you will see a lot more into what we're actually doing, because I'll a little bit get into as well of what this open source in our case actually means. So I'll quickly go through challenges, then the benefits, formulation, and then also the practice as well. So the challenge is maybe what the panel also talked about on the why it's not there yet, because I think people like to think also in energy market that energy is a very niche thing, but the question really how much it actually is a niche and how much it is using widely spread things in a very niche way, which means that you can do the business processes, if you break them down into small modules, it actually is doing the same thing as any other sector is doing, is exchanging data, providing data, storing data, and all these are small modules of a larger picture. And if you break it down to small pieces, the energy market is not special in any way. The problem is that there is a lot of existing proprietary software, as mentioned a lot, and it's always the promise that there's going to be quick changes. So 2 weeks in gonna be a new release, in then it is 1 month, and then you're gonna get a version that's not excellent because there may be only 1 or 2 experts in this company at all who actually understand that very specific standard. So what you need there is actually a bit more people and more robustness into this, and that's where I'd say the community as such comes into play. I think one of the challenges as well is that grid operators have lost a lot of development competence, exactly because I think all the companies are being lowered in that month due to the tariff setup as well, and a lot of things go to the investment. And as an investment, it's easier to buy it from outside, it's easier to capitalize the cost, and that what it has done over time is the competence actually moved from the TSOs to the providers. And I really true believer that open source is a way how to bring this competence actually back to the TSOs. It's not maybe direct open source, but open source is an enabler of actually having the competence back into the TSOs as well. And that's where my heading for the first page started as well. And of course, in the end, when we're talking about the tariff environment, it's always the question, where's my asset? Because asset is always a thing that you can monetize and capitalize, and also is a large impact on the tariff discussions as well. And I really see that this is where a problem as well. What looking at the commission side as well is to also think about it, that whether the tariff setup on asset-based capitalization is actually the correct thing. But then building a community is a very complicated thing, and this, I believe, it's something that is mainly because of the limited users, because as an RCC, our clients, majority of them are TSOs, and there is only so many TSOs that you can have. And if you consider maybe the partnership with other RCCs also, I mentioned at the beginning, there's only 6, which means that it's a limited community, and that the corporate structures is maybe what I covered with our ball points as well, is always an issue that you can't go and say, okay, open source is now the thing. Everybody to change their minds because they've done it for many years before, and they have this prejudice over open sources that if it's public, then it must be very dangerous as well, because there's gonna come somebody in the code modify something, but that's something that you're actually managing in a different way, this security part as well. But what about the benefits? I mean, because for us, we started on a blank sheet in a lot of sense. I didn't mention that we were established actually 4 years ago. So we started on a blank sheet. We cut some servers, and then how to actually start from the blank sheet. And I truly believe that open source is very good as a starting point, because now everybody talks about that we should have been done 10 years ago, why we're not. And when we started on the blank sheet, we thought, let's start from the correct starting point, because that's the benefit that we have. And maybe here some of the arguments when we were considering how do we do it, is that the vendors always. So you can go to a vendor. There are a lot of vendors who are very large and promise you everything. And the vendors, I'd say, is not the enemy, because the problem comes when the vendor provides you the code that's closed that you then want to change, and then comes the question, okay, you already have invested so much money, invest a bit more, and then invest a bit more than that, and what you end up is basically buying the same thing and paying basically the community inside that one company to actually develop that solution, other than actually having the code open and giving it out to the other providers as well. And again, here, maybe the community part is the thing that we talk a lot about the community, but when we talked about in the panel as well about the starting position, I'd say the starting position is make a GitHub account for your company and put something out there. And I mean, that's really is the easiest way how to start on the open source, is to put information out, because if it is a good thing, it's going to be picked up as well. Because the better your solution is, the better it's in the end going to be also, and the people kind of notice and they kind of ask about it, and you can then share it. But also, what we have seen is that our engineers who are developed the solutions as well have shared them and are being now asked the questions about the software solution itself and are actually able to explain, and they kind of have become the center of the competence of that business as such. Second thing, of course, is that open source means the code is open, which means that if we want to get support for that, our procurement document is we share a GitHub link. We give this document that please provide support for this. You know, in other words, if you want to change the provider, it's basically we have a thing that does a thing. Now please provide us support, which means that you're never going to find anybody to provide support for that, because nobody's going to accept that risk as well. And from when we started, or for maybe our journey as well, where we started, is that we basically did not have much, but we had a base softwares or base platforms, as we call them, or I think a wider term as well, that does a very specific things that we are using, and we are not setting up the environments from the base. And all the environments that we're using as a modules are already open source. And that, I think, on the last slide, I will share as well why we're actually, I think, invited here as well, is one of those blocks inside our system of blocks is PowSyBl as well, because it does a very specific thing. It is very easy to integrate. We're actually using the Python integration as well, which is the main back and forth loop for information as well. And I don't fully agree with the statement that Python is for scripting, because the power of Python is actually, I would say at this point in time, thanks to the support of the community as well, I'd say has bypassed the Java and is actually going to be safer, faster, and better in the long run, in the 10 years as well, to be used as a professional software. Maybe that's a formulation. So as we took the benefits and harms.
Like we're hitting a little bit the limit, but like maybe if you can be quick.
Yeah, I think I'll go to this slide, because it is basically for us. What we do as an open source, we are not providing open source as a tool. We provide open source the business, because what we do is we are integrating services using those modules that are open source and putting on the GitHub actually the business model that we do, the code base and the standard implementation of the specific things with all RCCs have to do. And our main aim is we share to standardize. We share the implementation to show how it actually should be, or how we see it should be done. We get feedback on different ways how to implement it, and the target is to share in the end that the business is what is open source. And in the end, the target is to actually get the best possible service from aligning with the different partners as well. I think all other points I mentioned. I like that RT mentioned also public money, public code, which I think is a very good term there as well. Very quickly, the stack we use, PowSyBl mentioned here, but I believe that's actually a good place to stop as well, because I really want to get the questions as well.
Thanks, Vico. Like really, really great inspirations, great statements. Really loved your deck. You also got a lot of hearts and likes. Yeah. Are there any questions for Vico? Maybe till then, Boris, like you shared some hearts, like what was resonating?
Yes, a huge kudo, Veiko. Thank you so much. We didn't met, and I never seen your deck slide before this event. So thank you so much. His testimony is tremendous. So yes, a lot of it from Artie and Boris, personally.
Thank you. I'd say for us, the kind of what made the decision obvious as well is to continue was to have a hammer basically sitting on the shelf and taking it and using it, which means it makes so much. It was really one of the point that made us decide that, okay, if we have already this hammer on the table, why go to somebody and pay for the hammer? So that's to Artie as well. What you've done over the years, I think that's amazing, and continue to do that. I think we will not be the last ones to actually make that shift as well from their side.
Awesome. Yeah, like I know the live stream is a little bit behind, but I'm just seeing the time. Unfortunately, we are hitting the limit now. I thank everybody here, I mean, like all the speakers, all panelists, all viewers that joined us today. I think on tops we had 200 folks on YouTube. But what's cool is that all these resources that we gathered here, they are actually there for a long time. Like the stuff is recorded. We will upload this to YouTube. And yeah, have this talk as an inspiration for many other generations. Well, let's see how long it's up and running. But yeah, let's push together, you know, like the next boundaries in the open source world. Let's bring in more money, developers, and so on, and make open source a success. Thanks again for attending, and have a nice day. Thank you. Bye-bye.